In this lesson, I'm going to teach you how to sketch the graph of a radical function given the graph of a quadratic function. So taking a look at my graph here, I'm given a quadratic function, and you know it's quadratic because it's a parabola. And I want to define or draw its corresponding radical function. So just like in my last lesson, there are 4 simple steps in doing this. The first step is defining the domain of the radical function. Y is equal to the square root of f of x. To find the domain of this function, you take a look at the original function. Y is equal to f of x. And you know you cannot take the square root of a negative number, so you use that property to define the domain. So f of x has to be greater than or equal to 0. It cannot be negative. So using that property, we're going to take a look at the graph where it's greater than or equal to 0. In other words, we're looking at pieces of the graph where it's above the x-axis. Okay, so there are actually 2 pieces of the graph where it's above the x-axis. The first piece starts at 4 and rises to the right. That's the first piece. The second piece starts at -3 and rises to the left. So those are the 2 pieces that lie above the x-axis. Therefore, my domain of my radical function is going to be as follows. So taking a look at the first piece, x is everything to the right of 4. So x has to be greater than or equal to 4. So that's the first set of domain there. And the second domain would be everything to the left of -3. So x is less than or equal to -3. That is the domain of my radical function. So we have a general idea of where the graph is going to lie, but we don't have a good idea of what the shape is going to be. So to look at the shape of the graph, we take a look at step 2. We want to mark the invariant points. Remember, the invariant points are the points in common between f of x and the square root function. To find the invariant points, you take a look at the graph where y is equal to 1 and y is equal to 0. So let's start with y is equal to 1 first. Find y is equal to 1. And there's actually 2 points on the graph with this y value. There's one right there, and the second one lies in the negative quadrant right there. Okay, so we have two invariant points so far. We have to find the other invariant points, and that comes from the fact that we have y is equal to 0 as an invariant point. So find 0, that's right at the origin. And once again, there's actually 2 points with this y value. There's one located right there at 4, and a second one at -3. So we know these 2 or 4 points lie on the graph of the radical function. So we label them, we mark them, and that's it. So those are the 4 points that we know will lie on the radical function. Okay, so to find more, to have an idea of what the shape looks like even more, we're going to go to step 3. And step 3 asks you to identify other points above the x-axis. So find other points on the graph where it's above the x-axis. So I'm going to select 2 points here. I'm going to select one way to the left here, right at -6 and 3. So we'll pick that point right there. So -6 and 3. And another point we will select is right at 7 and 3. So you want to pick points that you know you can identify and it's easy to read. So there are my 2 points. And what you want to do now is you want to take the square root of that point, meaning take the square root of each of these y values that you obtain. So we're taking the square root of 3, and we're going to round perhaps to the nearest tenth, okay? So square root of 3 is equal to approximately 1.7. So if I take the square root of that y value, I get an approximate value of 1.7 on the radical function. So what you want to do is graph these 2 points. So 1 point at -6, 1.7. So let's graph that. 1.7 is about here, okay? And then the second point, actually I'll do that in red there. So this is -6, 1.7, and then the second point is going to be at 7, 1.7, and that's going to be right there. So I believe we have enough points to draw this graph. So let's start with the right hand side here. We have 3 points, and I'm going to draw a smooth curve that goes through all of those points. So there's one section of the graph. And the other section of the graph is where it's negative. So we're going to start at -3, and we're going to draw a curve that goes through all those points. So the radical function graph is defined by the red curve, and that is how you sketch the graph of a radical function given a quadratic.